The Semnan province stretches across the southern edge of the Alborz Range and the northern rim of the Dasht-e-Kavir Desert in a band of terrain whose character shifts within 50 kilometers from alpine forest to salt flat, from green ridgelines that hold moisture from the Caspian to a void of white crust and baked clay that holds nothing at all. The Iranian space and missile program chose this province for the same reason it chose every operational site in the interior: distance from the borders, geological stability in the mountain-desert transition zone, and the specific quality of isolation that comes from terrain no one crosses without a reason. The Imam Khomeini Space Center sits in the Semnan Desert at coordinates that every major intelligence service has known for 20 years. It is the publicly acknowledged face of Iranian rocketry in this province. The launch infrastructure, the integration facilities, the test stands whose firings produce the acoustic signatures that seismic networks record, and that atmospheric monitoring stations characterize, and that no serious analyst confuses with anything other than what they are. The acknowledged infrastructure was never the concern. The concern was what the imagery analysts had been arguing about for 7 years in a ridgeline 14 kilometers northeast of the Space Center's perimeter. A pattern of construction activity that had appeared, persisted through completion, and then disappeared. Not ceased, but disappeared, leaving a surface that looked unremarkable. And that was, the analyst had been insisting with increasing confidence, the finished exterior of a facility whose interior had moved entirely underground. The facility that the target folder described was a production plant, specifically the plant producing the solid fuel propellant grain that the Iranian ballistic missile program had been transitioning toward in its most capable systems. The distinction mattered strategically. A liquid-fueled missile requires hours of preparation, providing a detection and preemption window. A solid-fueled missile is ready in minutes, requiring nothing from an observable logistics chain. The facility was producing the grain that converted a missile from a device requiring preparation into a device requiring only an order. The production rate, cross-referenced against inventory growth in IRGC missile units, supported a fielding timeline that threat assessments had been describing with escalating urgency for 18 months. The targeting decision followed. The facility's depth profile was the mission's first significant constraint. The propellant production process requires controlled environments, specific temperature ranges, specific humidity levels, specific isolation from vibration that could compromise curing batches in progress. And the underground facility had been engineered to provide those conditions at a depth that offered both geological stability and protection against surface strike effects. The primary production chambers sat at 68 meters below the ridgeline surface, in a layer of consolidated sandstone that provided the vibration isolation the production process required, and that presented to the GBU-57's penetration capability at the delivery geometry the defense architecture permitted, a materially harder substrate than the limestone formations of previous targets. Sandstone's compressive strength varies significantly with cementation quality, and the Geological Survey had established the Semnan ridgeline sandstone as well cemented, the upper end of the sandstone hardness range, harder than the alluvial and clay substrates of some previous targets, and softer than the granite and basalt of others, but at a depth that placed the chambers at the boundary of reliable single-weapon penetration. 2 weapons were required. The employment solution placed them at the same aim point in a timed sequence: the first weapon's penetration channel, reducing the effective depth the second weapon needed to reach the chambers. The second constraint was specific to the facility's contents. Solid fuel propellant grain is an energetic material. not in the same category as a finished explosive warhead, but combustible under conditions that include the kind of overpressure event that a GBU-57 detonation produces inside a confined space. The weapons engineers who worked the kill mechanism had to assess whether the propellant material in the production chambers would produce a sympathetic combustion event upon weapon detonation, and if so, whether that event would be confined to the facility or would produce surface effects that created additional concerns. The assessment produced a range, depending on the quantity of cured grain in the chambers at the time of the strike. The sympathetic combustion could range from a contained secondary event that extended the structural damage within the facility to an uncontained event of sufficient magnitude to produce visible surface disruption. The intelligence assessment of the facility's production cycle, based on the timing of raw material deliveries, and the logistics signature of finished product movements to missile unit storage sites, placed the strike window during a phase when cured grain inventory was at cycle minimum, between production batches, after the preceding batch had been moved to storage and before the next batch had completed its curing cycle. Cycle minimum reduced the sympathetic combustion risk to the lower end of the engineer's range. The window was not guaranteed. The logistics signature that had established it was an estimate, not a measurement. The planners accepted the uncertainty and built the mission against the lower end of the range. The two B-2 spirits assigned to the mission lifted off at 11:44 p.m. and 11:52 p.m. The 8-minute departure interval was the standard separation used for two aircraft packages, requiring coordinated weapons employment at a single target. Close enough to maintain data link connectivity throughout the flight, far enough apart that their radar signatures presented as independent tracks if the departure was observed by any monitoring system. The routing to the Semnan ridgeline from the forward location required 14 hours and 11 minutes at the mission's cruise parameters. The approach corridor had been optimized against the Semnan sector's radar coverage geometry, which was oriented primarily northeast, toward the Caspian corridor through which a Gulf transiting threat would most naturally approach. The mission approached from the southeast, using the desert terrain's minimal radar reflection environment to reduce the background against which the B-2's signature would be evaluated. Desert terrain presents a lower and more uniform radar return than forested or mountainous terrain, which means the noise floor against which a radar operator looks for aircraft contacts is different. Not better for the aircraft, not worse, but different in a way that the mission's EW planning had been built around. The pilot of the lead aircraft had more total B-2 hours than anyone else in the unit. The distinction was visible, not in his control inputs, but in the quality of his attention during the transit. Not managed through effort, but through a settled presence that 21 years had built and that required no maintenance. His mission commander, 11 years younger, managed through deliberate effort and managed well. Both methods produced the same result at the release point: a crew that was present and functional when the aircraft arrived at the place where those two qualities were required. The first tanker contact occurred at 3:09 a.m. over the northern Arabian Sea, a routine transfer in calm conditions that completed in 16 minutes and that the pilot accomplished with the casual precision that comes from having done it several hundred times. The second contact occurred at 11:47 a.m. east of the Strait of Hormuz, placing both aircraft at their final fuel states for the penetration phase. The coordination between the two aircraft's contacts had been managed through the data link timing protocol that the mission planners had developed for this package, a protocol that ensured both aircraft arrived at the penetration corridor entry point within the 30-second window that the weapons employment timing required. Both aircraft arrived within 19 seconds of each other. The window was maintained. The electronic warfare package covered the penetration from assets across the Gulf region. The Semnan sector's long-range S-300 batteries were oriented northeast toward the Caspian corridor. Their angle to the mission's southeast approach reduced effective detection range but did not eliminate it. The EW package was built against the reduced but real detection risk. Two EA-18 G Growler flights from the carrier group managing S-300 suppression, a land-based asset from a Gulf partner airfield covering the inner ring systems. The inner ring around the Semnan facility consisted of two HQ-7 batteries and a single Raad system, a lighter defense architecture than the nuclear and command facilities of the interior, reflecting the facility's surface invisibility as a protection layer in its own right. The planners had assessed the inner ring as manageable with the available EW assets and had allocated coverage accordingly. The assessment encountered its first complication at 1:33 p.m. local time, when the signal's intelligence feed showed the Raad system activating in a full-power emission mode that the pre-mission database had characterized as its standby profile rather than its active search mode. Full-power standby versus active search was a distinction the passive warning receiver would characterize differently, and the distinction mattered for the EW allocation that the land-based asset was running. The allocation had been computed against the active search power level. Against full power standby, it was providing suppression that the EW officer, reviewing the effectiveness metrics on his display, assessed as adequate but not comfortable. Adequate meant the Raad could not generate a weapons quality track. Not comfortable meant the margin between adequate and inadequate was smaller than the planning had assumed. He did not report the reduced margin. The reporting threshold required a degradation below the minimum acceptable effectiveness level, and the Raad suppression was above that level. He noted it in his personal monitoring log and increased his scan frequency on the Raad's emission to detect any further activation changes. He was watching when the Raad shifted from full power standby to active search mode at 1:41 p.m., a transition that moved its detection capability from the baseline the planning had been built against to a higher performance state that the land-based EW assets' current allocation did not fully address. The shift had not been in the pre-mission database. The Raad was operating at a configuration that the signal's intelligence had not characterized as part of its normal operational cycle. The EW officer reported the shift at 1:41 p.m. and 12 seconds. The planning element acknowledged at 1:41 p.m. and 23 seconds and authorized a power reallocation from the HQ-7 suppression budget to the Raad's active search frequency band. The reallocation reached the land-based asset and was implemented at 1:41 p.m. and 47 seconds, 35 seconds after the Raad's shift to active search mode. In those 35 seconds, the Raad conducted 8 sweeps in an understated environment. 6 sweeps returned nothing above the noise floor. The 7th sweep, at 1:41 p.m. and 39 seconds, returned a contact at 27% detection confidence. The 8th sweep, at 1:41 p.m. and 43 seconds, returned the same contact at 33%. 27, then 33, a rising confidence trend in 2 consecutive sweeps that the Raad's tracking processor flagged as a developing track. Not a confirmed track, a developing one. The processor presented the developing track to the engagement controller with the interface indicator that the system used for unconfirmed contact status. A blinking symbol, range ambiguous, confidence below threshold. The engagement controller saw the blinking symbol at 1:41 p.m. and 44 seconds. He had been watching his sector under an awareness notification that the sector alert controller had issued 22 minutes earlier. triggered by an anomalous emission pattern in the EW environment that the sector controller had assessed as possibly indicating an inbound threat package. The awareness notification had elevated the engagement controller's monitoring posture without authorizing engagement. He was watching carefully. He saw the blinking symbol. He watched it through the 9th sweep, which returned nothing above the noise floor, the reallocation having reached full effectiveness between the 8th and 9th sweeps and the 10th sweep, which also returned nothing. The blinking symbol disappeared. The developing track that the processor had flagged had not produced a third consecutive return, and the processor had downgraded it to clutter status. The engagement controller had watched a developing track appear, persist for 2 sweeps, and disappear. In a heavily jammed environment, under an awareness notification, with a 33% maximum confidence level, and no third confirmation sweep. He looked at the symbol that was no longer there. He looked at his display for 4 seconds. He transmitted a contact report to the sector alert controller. 2 sweep contact, maximum confidence 33%, unconfirmed, assessed as probable, jamming artifact, no engagement action taken. The sector alert controller received the report and upgraded the sector to active alert status at 1:42 p.m. and 31 seconds. Active alert authorized engagement of any contact exceeding the minimum engagement threshold. The engagement authorization reached the HQ-7 batteries, the Raad, and the S-300 elements within the sector simultaneously. Every system elevated to active search mode. The electromagnetic environment that the B-2's passive warning receiver displayed changed in character within 4 seconds of the alert activation, from a managed suppression environment with isolated threat symbols to a dense, multi-emitter environment with threat symbols at multiple bearings, some active, some intermittent, as the EW package responded to the new activation pattern. The mission commander of the lead aircraft saw the display change and ran the geometry in the time available. The initial point was 6 minutes and 14 seconds ahead. 6 minutes in which the active alert had elevated every system in the sector to a state the EW package had not been fully configured to address simultaneously. He transmitted the contingency code that shifted the Growler architecture from its primary coverage protocol to the maximum output suppression mode that the planning had held in reserve for exactly this scenario. The shift cost the secondary coverage allocations, the suppression on the mid-tier systems that the primary protocol had been managing at adequate levels. The maximum output mode concentrated available power on the S-300 fire control frequencies and the Raad's active search band, leaving the HQ-7 batteries partially suppressed on their primary frequencies and not addressed on their backup frequencies. The HQ-7 batteries operated on their backup frequencies for the 4 minutes and 9 seconds that elapsed between the maximum output mode activation and the B-2's passage through their coverage envelope. On backup frequencies, partially suppressed by the Growler architecture's residual coverage, both batteries ran acquisition sweeps that produced returns consistent with weather clutter at the ranges and aspects from which the B-2 was approaching. The HQ-7 is a capable short-range system. It is not a system designed to detect low observable targets at the ranges from which the B-2 was operating. Its detection envelope against a cooperative target at its radar cross-section profile extended to ranges that the B-2's approach geometry placed it outside of. The sweep returns were clutter. The engagement controller saw nothing above threshold. Both batteries ran clean. The lead aircraft reached its first initial point at 1:48 p.m. The bay doors opened. The first GBU-57 released. The correction for the weapon's departure was smooth, practiced automatic, the pilot's hands executing what 19 years of this specific maneuver had built into his neuromuscular system below the level of conscious direction. Bay doors closed. Turn onto the second pass heading. The first weapon's penetration through the sandstone proceeded at the rate the geological survey had predicted for well-cemented material at this depth. The deceleration profile was consistent with the fusing algorithm's model through the first 40 meters. At 41 meters, the deceleration data showed a brief anomaly, a density variation that the survey had not captured, a cementation irregularity in the sandstone formation that presented the weapon with a harder layer than the surrounding material. The anomaly lasted for 3 meters of penetration, increasing the weapon's deceleration rate enough to cause the fusing algorithm to recalculate its depth estimate. The recalculation took 0.003 seconds. The revised estimate was 4 meters shallower than the pre-mission solution. The fuse fired at the revised depth. The detonation occurred in the upper sandstone formation, above the primary production chambers, but inside the fracture zone that the sequential employment solution required the first weapon to establish. The fracture pattern propagated downward through the anomalous dense layer and into the regular sandstone below it, reaching the chamber's ceiling, with sufficient structural compromise to allow the second weapon's energy to propagate through the fracture network. The trail aircraft's initial point was 4 minutes and 51 seconds after the leads. The active alert that had been running since 1:42 p.m. had produced no additional contacts in any Iranian system during those 4 minutes and 51 seconds. The sector alert controller had kept the sector at active alert based on the 2-sweep contact report. He had not generated additional contacts to reinforce the decision. He had not rescinded the alert because the absence of contact in a jammed environment is not evidence of the absence of threat, and he was experienced enough to know the difference between those two conditions. He held the alert. The trail aircraft entered the target area under an active alert that had found nothing for nearly 5 minutes and that would, in 37 seconds, find nothing again. The second GBU-57 released at 1:53 p.m. and 41 seconds. Its penetration followed the fracture channel the first weapon had established, the channel geometry guiding it through the dense, anomalous layer that had affected the first weapon's detonation depth without deflecting the second weapon's terminal path. The second weapon reached the primary production chambers at 66 meters, 2 meters shallower than the pre-mission solution, due to the anomalous layer's effect on the channel geometry, but inside the chambers rather than above them. Inside was what the kill mechanism required. The fuse fired. The detonation inside the primary production chamber produced the overpressure event that the weapons engineers had modeled against a minimum inventory of cured propellant grain. The inventory at strike time was not at cycle minimum. The logistics signature that had established the strike window had been accurate about the movement of the preceding batch to storage. It had not been accurate about a supplementary production order that had been initiated in the preceding week, advancing the start of the next batch's curing cycle by 4 days in response to a tasking from IRGC missile units requesting accelerated delivery. The supplementary batch was 14% through its curing cycle at strike time. A partial cure, representing a quantity of energetic material that the engineers had placed at the upper end of their assessment range rather than the lower end they had planned against. The sympathetic combustion event that the partially cured batch produced was not uncontained. The production chamber's structural walls, while compromised by the weapon's detonation, retained sufficient integrity to contain the combustion event within the underground facility. The surface above the primary chamber showed no manifestation of the secondary event. The seismic signature that monitoring stations recorded was consistent with a single high-energy underground event, the weapon's detonation, followed by a lower energy secondary signature 6 seconds later that was consistent with contained combustion in a confined space. The secondary signature reached 2.3 on the monitoring network's magnitude scale. The Semnan Provincial Seismic Duty Officer logged it as unusual. 2 distinct events, closely spaced, directional in a way inconsistent with natural seismic activity, and filed a formal anomaly report before the end of his shift. The garrison registered the seismic events at 1:53 p.m. The duty officer attempted contact on all channels, primary, backup, emergency intercom, and received silence across all 3. He dispatched the inspection team at 2:01 p.m. The team returned at 2:17 p.m. and reported the access tunnel, passable to the 20-meter mark, and blocked below it, a ceiling deformation consistent with overpressure from a detonation in the upper sandstone above the production chambers. He transmitted his report at 2:19 p.m. What had not happened was clear. Contact not reestablished. Primary production level not accessed. Operational status unknown pending engineering assessment. The 2 B-2s were converging on their post-strike tanker rendezvous at 4:07 p.m. when the intelligence feed showed the engineering assessment. Tunnel deformation non-recoverable. Reconstruction estimated at months. Both primary detonations confirmed. Secondary event consistent with contained propellant combustion. The supplementary batch the logistics signature had missed had contributed to the facility's destruction rather than surviving as a recoverable asset. The uncertainty had resolved in the mission's favor. The numbers that closed the package: 14 hours and 11 minutes of flight time for the lead aircraft. 2 GBU-57 massive ordnance penetrators employed in a 4-minute, 51-second sequential interval. 1 sandstone density anomaly at 41 meters that recalculated the first weapon's fuse depth in 0.003 seconds and shifted detonation by 4 meters without compromising the fracture channel geometry. 35 seconds of under-suppressed Raad active search that produced a 2-sweep rising confidence contact trend, 27, then 33%, before the power reallocation eliminated the 3rd sweep return and downgraded the track to clutter. 1 supplementary production batch that the logistics signature had not identified, 14% cured, that produced a secondary combustion event contained within the facility and extending the structural destruction beyond the primary chambers. 0 aircraft lost. Both production chambers eliminated. The solid fuel propellant grain production capacity that had been converting the Iranian ballistic missile inventory from a force requiring preparation into a force requiring only an order was permanently removed from the equation. The difference between a missile that takes hours to prepare and one that takes minutes is not a technical distinction. It is a strategic one. It is the difference between a weapon that can be preempted and one that cannot be assumed to be preemptible. The facility beneath the Semnan ridgeline had been producing the chemistry of that distinction for 6 years. On an afternoon when the propellant batch in its curing chambers was 14% complete and would remain that way, the distinction it had been manufacturing ceased to accumulate. The sandstone holds its fractures. The production line does not hold anything now.